This is the real-time rows, and I'm going to show you a cool way to solve this problem. It's very powerful, and it deals with prime factorizations. So we're not going to have time to go over everything about prime factorizations. So if I talk about something that's a little confusing, you can always look that up by researching prime factorization, which is a super powerful technique for dealing with anything with multiples, dividing, factors, etc. So when I say pick a positive number which is divisible by both 12 and 15, let's look at the prime factorization of 12, which we can figure out by doing a factor tree. So 12 is 3 times 4. 4 is 2 times 2. So then read off the bottom row of this, and that is the prime factorization of 12. It is 3, 2, and 2. Let's also do the prime factorization of 15. 15 is 3 times 5. That's a pretty simple one. Now, the smallest number, which is divisible by both 12 and 15, we're going to build that new number. Let's call it x. And if it's divisible by both 12 and 15, it will have all the same prime factors as both 12 and 15. But you don't need to duplicate things. So for example, x must be divisible, if it's divisible by 15, it must be divisible by 3 and 5. Because that's what it takes to be divisible by 15. Now if it's divisible by 12, it must have a 3 and 2 2's. But we don't have to add an extra 3. We just need to have at least one 3, which we already have. And we need to have 2 2's. So this mystery number has the following prime factorization and will be divisible by both 12 and 15. So now in order to figure out what the mystery number is, we just have to multiply all of these prime factors together. So 2 times 2 times 3 times 5 is 60. And that is the smallest positive integer which is divisible by both 12 and 15.